Hello children, the continuation of electricity. In that, we'll see the direction of electric current. See, till 1890s, the negatively charged electron was not discovered. The scientists arbitrarily they assumed that the direction of flow of electron, the electric current was from positively charged body to the negatively charged body. That is known as convectional current. So later on it was discovered that in metallic conductors, free electrons are the carriers of electricity, and hence the flow of electrons constitutes the electric current. Therefore, the direction of flow of electrons is opposite to that, the convectional current. See, the conventional current, that is the direction of flow of positive charge, that means from positive terminal to the battery to the negative terminal of the battery, which is known as a conventional current. The flow of electrons, which is nothing but the direction of flow of electrons, gives the direction of electric current. It is opposite to the conventional current, as the electrons flows from negative terminal to the battery to the positive terminal. Okay. That electric circuit, the electric circuit, which is nothing but it is a continuous and closed path of an electric current. See the diagram, which is consists of a cell, electric bulb, an ammeter and a plug key. See the direction of current. It is started from negative and accumulated to the positive. See the symbols of components used in electric circuits. An electric cell, big leg, that is positive and negative, it should be like next. Plug key, which is switch is open. An electric bulb, variable resistance, that is a rheostat. Ammeter with a positive and the negative terminal. A wire which is joined, you have to keep a dot. And see a battery of combination of cells. If they asked cell, you have to draw like a one positive leg and negative leg. A battery, if they asked in the circuit, you must draw like a combination of the positive and the negative legs. Okay. The plug key, which is closed, you must draw like this. Resistor, voltmeter, a wire crossing without joining. See, these are all some electrical symbols you must know. That is, this is the basic electrical circuit, which is switch is open and cell, one cell and two cells in series. If they asked, you have to draw like that. 6 cell battery, you have to say that is battery more than 2. Wire conductor connecting cable and one resistor, resistors in series, crossing not connected. See, if the wire is not connected, you have to draw, that is not connected. Crossing, that is connected, there some connection is there, you must draw like that. Positive negative symbols you knows very well. And 2 cells in parallel. See, parallel means positive connected, negative connected. See, all the 3 cells parallel also, all the positive legs connected and going one side on all the negative. But in series, positive negative, like that it should be connected. You must know all those things. Earth connection. See, capacitor or a condenser, you must know to draw the differentiation between the battery, that means a cell, and the capacitor. When you drawing the cell, the one leg should be bigger, another one is small, but the capacitor, both the legs should be in the same size, right? So 2 resistors in parallel, 3 resistors in parallel, the resistor symbol with the symbolic representation, right? So switch is open, winding soft ion core, rheostat, fuse, variable power supply, ammeter, voltmeter, voltameter and the galvanometer with shunt. Only galvanometer means the resistor should not be connected. Got it? And now we can move on to Ohm's law. See what does Ohm's law says and how it's connected, the potential difference and the current flowing through the conductor, and what Ohms derived with the help of these things. See, Ohm's law is the relation between the potential difference across a conductor and the current flowing through it. It states that the current flowing through a conductor is directly proportional to the potential difference between its point or between its ends provided its temperature remains constant. That means the current is directly proportional to the potential difference I, which is directly proportional to V, or we can say V, which is directly proportional to I, or V by I, which is equal to constant, that constant, proportionality constant, that is Ohm's law. R, the R, which is the resistance, and we can call it as a proportionality constant of a given metallic wire at a given temperature. See, with the help of this circuit, the verification of Ohm's law, we can verify the Ohm's law, how the potential difference and the current is directly proportional to that. Right. Set up the circuit, what you have shown in the circuit diagram. First, use one cell and note the current and with the help of the ammeter, the potential difference with the help of the voltmeter across the resistance wire. Any resistance wire you can use, like nichrome. We have to repeat by using 2 cells, 3 cells, 4 cells, like that. We have to repeat it and get the readings through the ammeter and the voltmeter. And finally, we have to plot a graph between the current and the potential difference. The graph will be a straight line. With the help of the graph will be the straight line. It shows that the current flowing through the conductor is directly proportional to the potential difference across its ends. So this is the graph. You will get the graph. Now resistance. See, resistance is the property of a conductor to resist the flow of current through it. So according to Ohm's law, R, which is equal to V by I. The SI unit of resistance is ohm. If the potential difference across the two ends of a wire is 1 volt and the current flowing through it is 1 ampere, then the resistance R of the conductor is 1 ohm. Since we know that I, which is equal to V by R, the current flowing through a resistor is inversely proportional to the resistance. So that the resistance is doubled, then the current gets halved. Got it, children? Thank you, students.